In this video, I will show you a real-time equipment monitoring system that used in a factory. Conceptually, within a factory we have several areas such as the boiler room, compressors, water treatment, and other supporting areas. Each area contains several pieces of equipment. For example, in the boiler area, we typically have equipment such as the boiler unit itself, burners, feed water pumps, and other supporting systems. These pieces of equipment will be the main focus of our monitoring system. Each piece of equipment has several variables that need to be monitored. For example, in a boiler unit, these variables include the operating status, whether it is on or off, pressure, temperature, water level, and other related values. These variables are continuously monitored, and when any of them exceed the predefined limits, the system will automatically record an alarm for further analysis and action. Here is the communication architecture used to build this system. First, each piece of equipment is equipped with several sensors to measure critical parameters that need to be monitored. In this example, I use Modbus communication for each sensor. The data from Modbus is then read by Node-RED and stored in a database. In this video, I am using a PostgreSQL database. In addition, the data is also visualized using the Node-RED dashboard. This is the Node-RED dashboard built using FlowFuse that I created. This is the configuration page, where we can manage master data such as areas, equipment, and the variables that will be stored in the system. On this page, we can create, edit, and delete master data stored in the database. The area, equipment, and variable data are all interconnected. For each variable, there are several configuration details, such as the IP address of the Modbus server to be read, the register address, high and low limits, hysteresis, and other related settings. These configurations are critical to ensure that the system reads the correct values and writes accurate data to the database, preventing errors in monitoring and alarm handling. In addition, I also provide a feature to download the data in Excel format. This makes it easier during the installation process to review and collect all predefined variables that have been configured in the system. This is the real-time dashboard page. On this page, there are several sections. The first section is the equipment status overview. Here, we can see all machines registered in the system along with their current status, whether they are running or stopped. The status of each piece of equipment is updated in real time, allowing us to monitor the condition of all equipment at a glance. Additional information is also provided, such as today's running time for each machine, which helps operators understand equipment utilization throughout the day. The next section is the variable reading update. This section is presented as a table that displays all variables, grouped by their respective areas and equipment. The table shows the latest recorded value for each variable, along with a timestamp of when the data was stored in the database. It also indicates the current status of each variable, whether the value is within the normal range or outside the predefined limits. When a variable exceeds its limit, the status is highlighted in red, making it easier to quickly identify abnormal conditions and take action. This variable status data plays an important role in real-time monitoring. Each variable is continuously evaluated against its configured high and low limits. Based on this evaluation, the system determines the current status of the variable, whether it is normal or in an abnormal condition. This approach allows operators to focus not only on the raw values, but also on the actual condition of the process. By using clear status indicators and color visualization, potential issues can be identified quickly without the need to analyze each value manually. The third section is the active alarm list. This section displays all currently active alarms that are generated when variable values exceed their predefined limits. Each alarm entry includes detailed information such as the area, equipment, variable name, current value, alarm status, and the timestamp when the alarm was triggered. This information helps operators quickly identify the source of the problem and understand the severity of the condition. The list is updated in real time, so alarms will automatically appear when a new issue occurs and disappear once the condition returns to normal. By presenting active alarms in a clear and structured list, the system enables faster response, better decision-making, and improved operational safety. The next page is the area-based monitoring page, and this example shows the monitoring view for the boiler room area. Each piece of equipment is organized into its own group, making the layout clear and easy to understand. The color of each group indicates the equipment status. Red means the equipment is stopped, while green indicates it is running. Within each group, there is a table displaying the latest variable readings along with their current status. At the bottom of the page, I also display charts that show the last 10 minutes of data for each variable. These real-time trend charts help operators observe short-term changes, identify abnormal behavior early, and understand how values evolve over time, rather than relying only on a single snapshot value. This is also the detailed monitoring page for other areas, such as the compressor area and the water treatment area. Although the types of equipment and variables may differ between areas, the overall monitoring concept remains the same. Each area has its own dedicated view that groups equipment logically, displays real-time status through clear visual indicators, and presents the latest variable readings in an organized table. This consistency and layout allows operators to easily switch between different areas without needing to relearn how the dashboard works. By providing a focused monitoring view for each area, the system helps ensure that critical equipment in all parts of the factory can be monitored efficiently and reliably in real time. The next page is the history data page. On this page, we can select which variable we want to view historical data for. In the pop-up window, we can search for a variable based on its area and equipment name. After selecting the variable, the next step is to choose the date for the historical data. Once the date is selected, the page will display several groups of information. The first group shows basic information about the selected variable. The second group displays the historical data in a table based on the selected variable and date, along with a chart that visualizes the data for easier analysis. The third group shows the alarm history that occurred on the selected date, allowing users to correlate process changes with alarm events. In addition, I also provide a feature to download the generated data in Excel format. This feature allows users to export historical variable data and alarm records for further analysis, reporting, or documentation purposes. By downloading the data into Excel, users can easily perform offline analysis, share the data with other teams, and keep records for audits or performance reviews. This makes the system more flexible and practical for daily operations as well as long-term data analysis. Thank you for watching. That concludes this video on the equipment variable monitoring system. I hope it was useful for you. Don't forget to like this video and subscribe to the channel for more content. See you in the next video.